everybody, this is section 2.2 from our Hawks Learning College Algebra textbook, and this is Math 101 College Algebra, and we are going to look at linear inequalities in one variable today. All right, so here we are going to solve some inequalities, and solving inequalities is very similar to solving linear equations. The only time it's different is if we have a negative coefficient, and when we reach that, we'll talk about what we would do there. So to solve A here, what we are going to do is first, we do need to distribute to simplify each side. Then that's going to give us, do it over here, we'll have 5 minus 2x plus 6, because the two negatives make that a positive, is less than or equal to -1 plus x. And then we do want to simplify the left-hand side, because we can do that a little bit. 5 plus 6 would give me 11 minus 2x is less than or equal to -1 plus x. And then we'll move the x's to one side. So I'm going to choose the smaller of the two. So I'm going to add 2x to both sides. And again, be conscious of your inequality sign. Don't change it. -1 plus 3x is greater than or equal to 11. And now to solve it, we're going to add 1 to both sides. So we get 12 is less than or equal to 3x. We'll divide by 3, and x, or let me fix that, I should say 4 is less than or equal to x. And now what they want us to do is they want us to write this in interval notation. So remember, interval notation is using your brackets and your parentheses. If I were to graph this on a number line, here's my number line, it's going to be small, but 4 is my stopping or my starting point. And we know that 4 is less than or equal to x, so that means x is greater than. So if I were to graph it on the number line, I would move it and it would look like this. So the arrow to the right would be shaded. So what I'm going to do is when I do my interval notation, we have the line underneath, so we need the bracket. We'll do the 4, and then because it's shaded to the right, we're going to put our infinity and parentheses, so that would be our interval notation. Now let's take a look at B. Again, it's darn fractions. We don't like them, so what we're going to do, remember, multiply both sides by a common denominator. So if our denominators are 2 and 4, we can use 4. So multiply by 4. The nice side is the right-hand side, because remember those 4s will cancel out. So it really becomes 5a is greater than, and then here, remember the 2 goes into 4 2 times. So now you're just going to do 2 times 3, which gives us 6 times a minus 2. And now we'll distribute. So we have 6a minus 12 is less than 5a. Let's see here. I'm going to subtract 5a when I'm solving it. So I'm going to write it up here. A minus 12 is less than 0. And then we'll add 12 to both sides. So now we have a is less than 12. And when I go to graph this, again, if I were to put it on a number line, 12 is my stopping or my starting point. A is less than that, so it would be shaded to the left. So if I put it in interval notation, we're going to start off with negative infinity to positive 12. And because it's less than with no sign, or no equal sign underneath, we're going to put the parentheses around the 12. And that would be our answer in interval notation. right, so now we're going to solve compound inequalities. What makes an inequality a compound inequality is that there is an inequality on both sides of the problem, so like the front and the back of the problem. When you're solving an inequality like this is always going to be an inequality with an intersection, so an and inequality, where you include everything that is between the two values, your stopping and your starting point. And you can solve it. I usually solve it as one problem. I just create and I solve both sides at the same time. You can do it separately if you want. Now, the first thing we need to do to solve this one is we want to simplify this middle part. It looks crazy right now, but really, excuse me, we can add 67, 82, 73, and 85 together to simplify it. And when we add them together, we end up with 80 is less than or equal to 307 plus x divided by 5, which is less than 90. So what we're going to do to solve this is first, I would get rid of the 5. They divided by 5, so we're going to multiply everything by 5. Or think of it as like 5 over 1. So 80 times 5 is going to give us 400. Is less than or equal to, and then 307 plus x divided by 5 times 5 will just leave us with 307 plus x, which is less than 90 times 5 is 450. Next, to solve, we will subtract 307 from both sides. And we end up with 93 is less than or equal to x, which is less than 143. Right, now, if they were to ask us to put this into interval notation, remember your sign is going to follow what your inequality sign is. And in this case, because it is a compound inequality, we have a stopping and a starting point. We won't need infinity. 93 is my smallest value, so that's my starting point. 143 is my stopping point because it's the highest value. X is greater than or equal to 93, so that means around 93 we'll put a bracket, but x is less than 143, so that means parentheses. And that's it for that problem. Now we're going to take a look at B. This one is nice because it's already simplified for us, so now we just need to solve it. And what I'm going to do is, it's another compound inequality, so I want to isolate x. So the first thing I'm going to do is get rid of that 3, so I'll subtract 3. But because it's a compound inequality, we have two inequality signs, I have to subtract the 3 from all 3 parts of the problem. Think of the inequality signs as dividing up the problem into parts. So -1 minus 3 will give us -4. And that is going to be less than -2x, because my 3's will cancel, which is less than or equal to 2. And then the last thing I'll do is divide by -2. So now I'm going to have -4 divided by -2 is 2. So 2 is less than -2 divided by -2 is a positive x. And that is less than or equal to 2 divided by a -2 will give me a -1. And there's one thing that I need to do that I did not do when I did my division. Because I'm dividing by a negative, the final step that I need to do, if you recall, when you divide by a negative, you have to flip your inequality signs. So really my answer is 2 is greater than x, which is greater than or equal to -1. So I had to flip those inequality signs because I divided by a negative. And now when I write it in interval notation, my smallest value is -1, my largest value is 2, and the -1 is included, so it has a bracket, 2 is not, so it has parentheses around it. All right, so next we are solving absolute value inequalities. And one thing to note, when you solve an absolute value inequality, just like when we were solving absolute value equations, we have to create two problems or two equations or two inequalities. Now, the direction your sign is going will determine whether you create a compound inequality or two separate inequalities. So it'll really determine if your problem is an intersection, which is like the keyword and, or if it's a union, which is your keyword or, where you include everything in either problem. So here, if you have your problem, if the absolute value of x, or the expression, whatever it is less than a, then that is the same as creating a compound inequality. So you would take the opposite of a and make it less than the expression, which is less than a. Okay, so if it's less than, think one problem, even though there's two inequality signs in it, you create one problem. Now, if your expression is the absolute value is greater than a, when you solve it, it is the same as doing x is less than the opposite of a, so you take the opposite of that answer, or x is greater than a. So with greater than, think greater, you have two problems that you create. Less than, you create one compound inequality, one problem to solve. Now, just like with absolute value equations, the first thing you want to do when you go to solve is you do need to isolate your absolute value. So the first thing we're going to do is move that 2 over by subtracting 2 from both sides. And that will give me the absolute value of 3y minus 2 is less than or equal to 4. And now this is a less than, or it's less than or equal to, so that means that I'm going to create a compound inequality, and my 3y minus 2 will go in the middle, so I'll just put 3y minus 2, and I can keep the less than or equal to 4 here, and then this is greater than or equal to negative 4, because remember, you always want to do the opposite of that answer. And now we'll go ahead and solve it like a compound inequality. So I will add 2 to both sides. And that is going to give me negative 2 is less than or equal to 3y, which is less than or equal to 6. And then we will divide everything, all 3 sides, by 3. So negative 2/3 is less than or equal to y, which is less than or equal to 2. And if they ask us to put this in interval notation, you know, my starting point is negative 2/3. And there's a bracket around it because it does include it. And then my ending point is 2. And again, there's another bracket because it does include it. And that would be it for our first one. We're going to take a look at B in our next slide. All right, so now we're going to look at B. And for this one, the absolute value is already isolated. And if we look at this, we can see here that we have the absolute value of 4x minus 2x is greater than 6. Because it is greater than, this is one where we're going to split it up into two inequalities to solve. So we're going to break it up and solve. We will have 4 minus 2x is greater than 6, just like we had before, our original problem. But then we're also going to solve 4 minus 2x is less than negative 6. And now we'll solve the two inequalities. The first thing I'm going to do is to get the x by itself, I'll subtract 4 from both sides, and I'll do that on both equations. You can solve them one at a time if you want, or solve them together, it doesn't matter. I will put a line so you know they're two different ones. So now we have negative 2x is greater than 2. And then for this one, we have negative 2x is less than negative 10. Now we are going to divide both sides by negative 2. And if you recall, we're dividing by a negative. So that means that we need to switch our sign. So I'm going to do it now. And that's going to give me x is less than negative 1. And then over here, we're going to have x is greater than 5. And when I go to graph this, if I were to put it on a number line, here's my negative 1, here's my 5. Remember, it is x is less than negative 1, so it would include everything to the left of negative 1, or x is greater than 5, so everything to the right of 5. When I go to put that in interval notation, we will have, and you kind of write it like it looks on the number line, we would have negative infinity to negative 1, and they both get parentheses, because remember, around infinity, you always put parentheses, and our sign does not include negative 1. Then put your U for union to show that it includes both, and our next one is going to be parentheses 5 to positive infinity, and that would be our answer in interval notation. All right, and now we're going to take a look at our last example, and this one is one where if we look at this, we have less than or equal to, so I'm going to go think, okay, I need a compound inequality. But then I look at my answer, and we have an absolute value equation that is less than or equal to a negative number. Just like with equations, if your absolute value is equal to a negative number or an inequality with a negative, it is not going to work. It's going to have no solution because it should have a positive answer here. So for one like this, it would just be no solution. And that's all you would have to do with that one. You couldn't do any more. And that is it for section 2.2.